Hi, welcome to random forest algorithm session. The random forest algorithm is one of the bagging technique. So in bagging technique, we will use multiple multiple decision trees parallelly. We will train that. So here, the which is combining multiple learning algorithms that may be called classifiers or learners to improve the performance to solve the problem, which is one of the supervised learning. It can be used for classification and also regression, which is having several decision trees that is trained over various subsets of given data set. This is important. The subset is selected by using the row sampling and column sampling or feature sampling, which is computing average or majority votes to improve the predictive accuracy of given data set. Why do we need that random forest algorithm? As we have seen in the previous session, the bagging technique is using multiple models. When you are using single decision tree, there is the possibility of getting a low bias and high variance. That means you will get low error during the training phase, but high error you will get during the testing phase when you are evaluating the model. So to avoid that, we can use multiple decision trees combined together to provide the better result. So that process is called forest, combining multiple trees to make a forest to provide high accuracy, and it prevents the problem of overfitting. That means it is preventing the high error during testing phase. So it can be using for classification approach and also regression approach. The first step here is we have to collect the data set. Then we should make the subset of a data set which is selected by using the feature sampling and row sampling. And here we will assume m number of training samples are selected with n number of features. Based upon that, we can build the weak learners one by one parallelly. So first subset will pass into the weak learner 1. For example, the weak learner 1 is available here. For weak learner 1, we are passing the m number of samples and n number of features from n number of samples and r number of features. So here m is less than the n and n is less than r. So here for sample number 1, for example, which is predicted as the class A. For sample number 1, same sample number 1, the weak learner 2 predicted as class A. The for sample number 1, the weak learner n classified as class B. So here it is up, so this is called, until here it is called bootstrapping, right? Then here we are applying the aggregation approach, that is called majority voting here. So majority among these three classes is class A is occurred 2 times and class B is occurred 1 time. So this sample number 1 is predicted as class A. That is the uh, beauty of random forest classifier. So here we are training the weak learners parallelly. You look at that, this learner is also done at the same time, this is also executed at the same time. So all the weak learners are executed parallelly, so the time complexity for this method is very less. So here we have to repeat that process until we are getting uh, low error and high accuracy. So this is explained by using the code. Here I am using the default dataset, iris dataset, which is imported from the sklearn package and which is assigned into the iris variable. So here, which is having the set of features which is assigned into the capital X, and set of target values that is assigned into the small y. I want to know what are the data available in the features. So here four features available: sepal length, sepal width, petal length, petal width. then we are having around 100 number of samples. Then I am assigning the target labels into the y already assigned in the previous step. So now I want to print that values. So here we are having the three classes, class 0 and class 1 and class 2. We are having almost balanced data set. Then I am splitting that data set into training and testing samples. So here the x is assigned into the x underscore train and x underscore test, and the target label y is assigned into the y underscore train and y underscore test. Then I am using 25 percentage of samples as testing samples among the given data set. Then I am importing the random forest classifier from the Ensemble package of sklearn. Then here I am calling that method random forest classifier with the number of estimators. Here I am giving the 10. That means number of weak learners are here 10. This is one of the parameter we can pass into the random forest classifier. So for this data set I am going to use 10 number of decision trees or 10 number of weak learners. So then for the 10 number of weak learners I am passing the data x underscore train, which is splitted here. So that is given as a input. Then from this x underscore train we will predict the y value. We will predict the y, predicted y. The predicted y will then compare with the y underscore train. So after that it is constructed. Now model is constructed. That means model build by using the random forest classifier. So random forest classifier model is ready, which is assigned into the variable rf. Now I am passing the this 25 percentage of samples, testing samples, into the random forest classifier. Random forest classifier is having in the variable rf, then which is predicting the output for x underscore test. This is the testing sample variable, which is already we assigned from the given sample data set. So now which is predicting value for the x underscore test. Then I am comparing the predicted values for the features of testing samples. Then already we have actual output of these samples. We are comparing that, and after comparison we are calculating the accuracy. So here we are getting the 97.3 percentage of accuracy. Here if we want to look the fifth estimator, so as we have discussed, we had number of decision trees. I want to look fifth decision tree. The decision trees will start from 0 to n minus 1. Here we have given 10 decision trees, so 0 to 9 you can visualize. So fifth decision tree I want, sixth decision tree, that is index is 5. So I want to visualize. For that we need export underscore graph visualization package. So here that data will be stored in the form of dot files. Here it says feature name sepal width, sepal length, length, petal width. Then target names is here our target label. Then here we are calling the method check underscore call, which is used to convert that dot data into the png data. So png data, then I want to visualize the image which is available in the form of tree.png. You look at that fifth decision tree in the random forest looking like this. This is the fifth data estimator, fifth estimator in the random forest tree. First it is taking the petal length as uh, a more informative feature based upon the Gini index. Then whichever less than or equal to 2.45, which is going to here, and which is greater than that, which is going to here. So based upon that, here which is segregating the classes. So here leaf nodes, all the leaf nodes are giving you the classes. Then if I want to look zeroth estimator, first decision tree, which is looking like this one, which is taking petal length. The previous one is, it is taking petal length is 2.45. Now you look at that, it is taking petal length is equal to 2.3, less than or equal to 2.3. So each estimator is having different perspective. So based upon that, we will classify the given data set. So here we got 97.3 percentage of accuracy. So here we are having different estimators. We have different hyperparameters here, like number of samples split, minimum number of samples split for internal node. We can give as a parameter to the random forest classifier, and the minimum number of leaves, and the number of processors assigned, number of samples, maximum number of samples, random state we can give, class weight also we can give. So these hyperparameters can be tuned by using the grid search CV and random search CV, that already we have discussed in the decision tree concept. And also we can use a number of estimators, 10, 20, like that. Default value will be 100, so you can mention 10, 5, like that, for practice purpose. Then criteria is, here you can use either Gini entropy, Gini index, or entropy. Maximum depth of the decision tree you can set, and maximum number of features selected for each split process, random sampling, I mean sampling process, you can set it. And number of samples, subsets also you can set here. Number this is for row sampling, this is for feature sampling, you can set it. So these are all the parameters you can set for the random forest classifier. It can be done by using the grid search CV also for automatic selection. Thanks for watching.